Hello once again, this is presentation 7.6. The topic is the student t-distribution, and this material is in your book, chapter 7. Now we want to talk about the student t-distribution as compared to the normal distribution. As you can see here, the blue curve is a normal, and the red curve is a student t, and the red curve is more broad and flatter than the blue or normal curve. Now back to the normal curve. For 90% confidence, we're looking at the critical values of the tail, plus or minus 1.645, the red curve being the student t, and to preserve this region in the tails at 10%, corresponding to 90% confidence, we're suggesting those critical values are something above 1.645, in particular, they're 1.7109, and we're saying those values come from the t table, and here it is on the screen here. For fixed values in the tail region, the area under the red curve is greater than that under the blue curve. So there's a higher probability of getting an area in the tail under the red curve than is the blue. We're going to take an example here. We take a sample of n equal 25, mean systolic blood pressure computed to be x bar 129.4, standard deviation 5.8, confidence interval 90%, and we're saying, as above here, 90% confidence corresponds to an alpha value in the tails of 10%, in which case each tail is alpha over 2, in this case 5%. The area in the middle under the red curve is lower than that of the blue. And from the table over here, we're looking at degrees of freedom 24, and the area in the right tail, t.05, coming down there, 1.7109, and that's how we arrive at this value here. A sample 90% confidence interval for the mean mu becomes, here we go, it's your estimate plus or minus your margin of error, and your t is 1.7109. We use S as an estimate sigma, and this gives us our confidence interval here. We're 95% certain that this interval captures the true mean for the population. Now, looking more at the student t-distribution again, we have for 95% the critical values 1.96, and for the student t, depending on sample size, we can find our t critical values, as you see on the screen here. And as we said before, the area under the red curve in the tails is greater than that area under the blue. In the middle, the area under the blue curve is greater than that of the area under the red curve. And now we're going to look at these critical values again. If we're looking at a sample size n equal to 22, degrees of freedom, n minus 1 is 21, and for 95% confidence, the region of the tail is 0.025. Those are critical values. The critical value for t is 2.0796. And generally, if we call this alpha, the area, 1 minus alpha, the area in the tails become alpha over 2. And so t sub alpha over 2 in this case is 2.0796. As the sample size n increases, the t-distribution, the red curve, gets closer and closer to the blue. And as the sample size increases, the t-critical values become closer and closer to your normal values. And here they come on the screen here. Note, when n is large, we have these critical values at the bottom. The t and the z scores merge. So if you need to find out your z criticals, you simply need to look at the bottom row here of the t-distribution. And that's the end of presentation 7.6. Take notes and go on to 7.7.